Hello. I often feature audio and video equipment on this channel, and you may have seen me use an oscilloscope sometimes. I've got a TDS 3012 here. It's a very old oscilloscope, but it works quite well. There was a battery option for it, but this doesn't have it, and even if it did, it wouldn't still work. So that's not very portable. I also have sometimes put oscillograms straight onto the YouTube videos, for which I use this, but of course that's not a portable device either. So what me and one of my sons did, young Scott, we built this little oscilloscope here, and well, what can I say? It worked for a while. Now, even though the encoder works, unfortunately the attenuator doesn't, so that's kind of died. I just don't have any kind of portable oscilloscope at the moment.
Special delivery.
Ooh, I wonder what's in this. What do we have? Oh, it has its own built-in signal generator. That could save a bit of time. Waveform storage. Excellent. One key oscilloscope, so just auto set, like the big scope over here has got. And a built-in lithium battery. In a nice carry case too. So, TOOLTOP ET120MC2. We don't get the pleasure of a film to pull off this display, I don't think. Nice grippy feel to the case, that's quite good. And it sits up on the bench. Channel 1 and Channel 2 inputs and an output. Switch there which is not labelled, which I think is going to be on off, isn't it? Yes. Oh, it booted really quick. That's impressive. And where's the charging port? We'll find that in due course. We have a probe with the correct fitting here for the sockets. So of course that's much smaller than a standard BNC connector. So you won't be able to use your old oscilloscope probes with this. Not without some sort of adapter cable. That's when you just need to clip onto something and you don't necessarily need the performance of an oscilloscope probe. And a second probe. Excellent. And some instructions we really should read. So single channel bandwidth of 120 megahertz, hence the model number. Dual channel bandwidth of 40 megahertz. Sampling rate 500 megasamples per second. And it can do auto, normal and single sweep. Well, I'm going to use single sweep later. I've got a little circuit built to test it with. The user manual seems to be written in remarkably good English, which makes a real change. The only thing it might have benefited from is being in colour. Okay, and it tells us how to compensate the probes, and we'll do that shortly. First obvious thing to try. The charging port, I think, is there. There we go. It didn't seem to be mentioned in the manual, or if it was, I missed it. But let's charge it up properly before we start using it. That's not just a charging port, but we can also use that for pulling data off. And it's USB-C, our favourite. We like that. It does say in instructions, don't just charge it from the computer, charge it from a proper 1 amp supply. Let's plug a probe into one of these sockets. Oh, they feel very positive. Yeah, not bad at all. I don't think that'll fall out. I'll use this cable for the output connector. Let's start by giving it some simple repetitive waveforms. And an easy way of doing that, I think, is going to be use its own internal signal generator. So. And the signal generator, of course, can be used also for calibration of the probes. So gen out, okay. Square mode, yes. 1 kilohertz, 3 volt peak to peak should be ideal for just checking that we have the compensation correctly set on here when we're in times 10 mode, which we presently are. So we'll use this cable, which could be used for low frequency connections on the channel inputs as well as for the output. So we're using that on the output connector there. I don't know if it's necessary to connect the ground. I imagine the ground's common between the input and output sections, but let's connect it anyway. And then the signal. And we seem to have a slight problem. Does something look a bit loose on that? It feels a bit sloppy. Well, that one feels the same. Which is the one that's doing the slopping? If I hold that and wiggle that, it's going off. And if I hold that and wiggle that, it's not. So it looks like the output socket on this, the pin is presumably not making good contact. with the center conductor. Oh dear. Right, shall we? Yeah, I think we're going to have to fix that before we carry on. I'll look under the microscope. I think it may be just a case of closing up the conductor slightly so that it fits better on the center pin of this. Yeah, let's just check it out on the microscope. So looking at, we've got channel 1 and channel 2. It looks like channel 2 has been squeezed a bit already, and the output is definitely much too wide. So we need to squeeze those that sort of socket slightly together, I think. I don't know if you can see that. I think we're going to have to use some sort of tweezers to get in there. Okay, I've closed that up with just a set of tweezers like this. Okay, right, now I want to show you something I've just seen here. You could get, that could be a slightly misleading waveform. See, it's bouncing between nothing and everything. That could be, well, partly because of the trigger. Let's set the trigger level to 50%. Okay, and partly I think because of the sampling. But now if I adjust the time base, good, that's fine. Or we could hit auto and we get a similar result. Auto isn't incredibly fast. Let me just demonstrate that. So I press auto. It takes a few seconds but gives us the same result. So now we're seeing a nice waveform there, and it doesn't look like the probe needs any compensation. Actually, it was already set correctly. But let's just prove that that does work as well. So it comes with an adjustment tool. Undercompensated, overcompensated, correctly compensated. Right, let me show you something really important. Mode switches between here. This shows you, that means it's moving, and that means it's the gain in that direction. So this gives you amplitude or time base, and this gives you shifting. In this case I wanted to shift, so I want to shift down the screen a bit. There we go. Now it's inevitable, of course, you're not going to have, you know, a control for vertical and horizontal position, and a control for gain, and a control for sweep, you know, as nice little, you know, rotary encoders on something this small. You're inevitably going to have to use buttons, so you just need to keep an eye on that center marking there between those two modes. But we've got that set up nicely now. The red mark there is the trigger level, so that's set to 50%. How do we adjust it? Let me show you a little bit about triggering. So you can select between single, normal and auto triggering. We'll leave it in auto for a moment, and typically you'll hit 50% to get triggering at 50%, but if you need to trigger somewhere else, then we can use these keys to move the red marker that alters where the trigger is. If we go off, the bottom will become untriggered. And we can demonstrate that perhaps with, let's choose a different waveform. Perhaps if we go to a triangular waveform, then as we move the triggering, of course, it will move the whole waveform side to side, which is exactly what's happening. Okay, so the triggering seems sensible. I don't believe we have any sophisticated trigger systems on here, for example TV or anything like that. We've been using here just channel 1. If we want to switch on channel 2, you go over here and press and hold it, and then channel 2 will appear as well with everything connected at the moment. I'm going to be doing some tests on this which are a bit more demanding than just simple repetitive waveforms, and this is one of the circuits I've put together for it. It uses one of my favourite ICs, CD4017. It's a decade counter. So that's been fed from this 555 at a fairly slow rate, and two of the outputs which are connected to these LEDs. They're not immediately adjacent outputs. They go high for a while, but I'm not looking at the signal for those. I'm feeding those via some diodes to a capacitor, and so I'm getting negative and going pulses from this capacitor. So I'm getting fairly short pulses spaced by a long time apart. So that's a fairly demanding waveform to try to analyze. So I'll start by looking at that on the TDS3012, and then we'll see what we can get on the TOOLTOP device. So I think you can see these negative and positive going pulses going past. If we set to single sweep, we'll capture a set, and then what I can do is zoom in to the data and capture or get to view data that's in an event that's already gone. So you can see the fairly short pulse there where we've got 10 milliseconds per division. So we've got a pulse of sort of about fades away in about 5 milliseconds of 1 or 2 volts or so, which is happening only very infrequently in a waveform of several seconds. Okay, so we have smaller pulses and larger pulses here, and I can go in and look at these pulses after they've been captured. And there comes a point that, you know, we run out of samples and it all starts to break up into little dots. But our sample rate here is 1.25 gigasamples per second, you know, for a non-repetitive waveform. So that's pretty capable, but you have to bear in mind that though this oscilloscope is, I don't know, well over 20 years old, it was a very expensive piece of kit. Right, let's see if we can see any of that detail using the TOOLTOP. Right, let's have a look at it on here. I'll demonstrate it on the screen initially, but then we'll look at what happens with software that you can load onto your PC. Okay, you can see we are capturing the same sort of information, so it's not like we're completely failing to see these pulses. Can I alter the time base so we can see them in a bit more detail? So if I set the trigger to single sweep, okay, we can capture plenty of detail of that waveform, but it's a little bit difficult to see where that is in the overall scheme of things, because of course we had a much longer period, and what we can't readily do is zoom in on something that we've captured over several seconds. We have to trigger on it with a faster time base, but then we don't know which of those pulses we're looking at, because if you remember there were large ones and small ones. So yes, it can capture single shot quite well, but what we can't do is sort of zoom into its memory. It doesn't have enough memory. But you know, that was a particularly challenging waveform. Tell you what we might like to do is see if we can get any different results on this one. Is this any better at capturing that sort of waveform? Right, what I'm going to do now is connect it up to the PC and let you see with its own software some of these waveforms. And also, as we're going to be on a PC, I'll have a look and see with this PC based oscilloscope here whether that would do any better job. Okay, let's get the software started up. So here's our software. It includes a bit at the bottom of the screen for a version which has a multimeter, and we don't, so please just ignore that. Can we get rid of it? Oh yeah, we can pretty much get rid of it. Good. And we're running in live mode now with real wave. Slightly oddly, this has got a green trace, and what we see on the PC is red, but let's ignore that. So I put it into single step mode, so we've got a single sweep there, and you can see it on the computer. I would say that the version that's on the screen is possibly slightly higher resolution than what's on the computer. But what is nice is it does all the measurements as well. If you've got a frequency or period, obviously we don't here, but they all display on there as a matter of course. We can choose to select them on here through one of the menus. Our problem might be here if we want to go into any more detail on one of these pulses, say that negative going pulse there, we need to change the sweep speed faster, and we are doing that and we are seeing it, but we couldn't necessarily pick out one of the pulses from that chain. I don't think there'd be any way to delay the trigger to go and look at one of the later pulses. So we can capture the first one, but I don't know how we would capture any of those later pulses. So if we wanted to look at the second of the lowest pulses there, I really don't know how we could set about doing that. Alright, that's possibly a little bit too challenging, but you can certainly make some useful measurements here. Okay, next we'll have a look at the 01 oscilloscope and see if that does any better. So we're seeing a similar sort of result on this one. These occasional pulses flying by. Do we have any more options on the triggers? Yes, we could do hold off on this one. So we could potentially get it to trigger on the second pulse, but trigger mode is set to auto and it won't let us change because of the low sweep speed. So it doesn't actually get us a lot further on this particular waveform. Does the 01 do any better? It might have the potential to do better under certain circumstances, but not with this particular waveform. Right, enough with this little signal. Let's put this machine to some real work. What we're going to do is, if you're a regular viewer to my channel, you'll know I mess around with video recorders a lot. And I've got a Beta, or Betamax if you like, a Sanyo machine here, but the principles apply to nearly all video recorders. And it has, in this case, 2 video heads and a switching signal that switches between those two. And the RF envelope tells you a lot about the quality of the tracking and the video heads that you are getting from that machine. So it's the output from the heads. It just appears like a block of RF signal, gets decoded further down the line in the machine, and we're going to be looking at the shape of that envelope. It should be like 2 just blocks, 1 per head. This machine isn't perfect, and the RF envelope may distort slightly, and that's one of the things we're going to look at. So we'll look at that initially with the TDS3012, and then we'll see if the TOOLTOP and indeed if the 01 can also capture that RF envelope, because it's a non-repetitive signal. So it's going to be quite challenging for the devices which don't have such high native sample rate of capture. Right, let's set that up and have a look. So let me show you what we have here. The top trace is the head switching pulse. That tells us which head we're reading from. So the lower trace here is our RF envelope coming from the 2 heads. So that's one head and that's the other head. We've just got a repetitive waveform. The only information is what we're getting off these 2 heads. And if I adjust the tracking control on this machine, we will see the waveform slightly change. So we've got a full envelope on one head or a full envelope on the other, which implies there's something wrong with either the recording or the machine. It's not giving quite the results it should, but this is very much the sort of envelope you'd expect. And if I swing the tracking way off, then it just becomes a scrambled mess like that. And something else that's worth looking at is if I hit freeze frame, then it becomes disturbed because there's tracking noises on this simple 2-head video recorder. And if I hit picture search, you'll see multiple mistracks. Okay, so that is an RF envelope from a video recorder, and you could argue this machine could use possibly a little fine tweaking. So what you do is, with reference to this RF envelope, you would adjust some of the guides on the tape path to try to get that a little bit more flat at the beginning of the sweep. So This is a critical waveform to be able to view accurately for setting up almost any video recorder. Right, let's see what that looks like on the TOOLTOP device. So I'm going to set this up now. We want channel 1 to be our trigger. Okay, and now channel 2. What I hadn't shown you on the other oscilloscope actually is that there's a large DC offset on this signal. So going to channel 2, I'm going to select AC mode, and then we can see the RF waveform or the RF signal there. But are we really getting anything? It looks like the sample rate might not be high enough. Let's select pause. Can you kind of see a little bit? And then when you hit play, you can kind of see the waveform a little bit more. Hit picture search, you should have multiple. Yeah, sort of. But do you think you could set up a video recorder with that kind of waveform? I think the answer is no. There's not enough detail in it because the sample rate's too low. So for this kind of non-repetitive waveform, this kind of oscilloscope doesn't really do it. It's much better for repetitive signals. Shall we have a look and see if this device was any better at this same waveform? We'll give that a go just in case it is. I suspect it won't be, but let's have a look. Fairly easy to connect up because Sanyo provided us with a nice test port with the signals. Okay, so I've set up pretty similar parameters here on this scope. Again, if we swing the tracking from side to side, can we see the envelope? I think the answer is a little more. Try the fast forward. Yes, you can see a bit more on this one, but I would say that still you don't see anywhere near as much as you do with the Tektronix TDS3012, and I still think you'd have an awful job setting up the tape path on the machine with that kind of response. So I think what's happening is an awful lot of the time the samples are just missing the important part of the waveform, and so it bounces around a lot. So no, neither of these devices would do that particular task because of the non-repetitive nature of the signals. I just wanted to show you something that I'd found out by messing about, because it didn't seem to be in the manual, was the trigger can be on either of the channels. So I've got two frequencies going on here that are very close. There's the square wave 1 kHz coming from its own signal generator, and frequency here that's a little bit lower coming from this little signal generator, and that's the sine wave. So these two frequencies are not locked to each other at all. You can see that when we display them here, that the sine wave is drifting through. So the red marker here is showing us that we're triggering on the 50% point of channel 1, which is a square wave from its own signal generator. If I move focus over to channel 2 and press 50% on that, then the red marker goes over to channel 2, and you can see that we are triggering on channel 2, and now it's channel 1 that's unlocked. So that seems to be the way to set the trigger over from one channel to the other, and then you can manually alter the trigger level if you want. There you can see it's going up and down there with the trigger set points here, but it just seems to be the way to do it, is to set focus and then hit 50% as a quick way to move the trigger over. Something I wanted to show you, you can see we're generating a square wave from its internal frequency generator, but we can do a bit more with the computer. So we have the live waveform there, but we can also go to FFT, and we get an FFT analysis, so a time domain image of the square wave. You can see all the harmonics of a square wave. That option exists on a TDS3012, but it was a very expensive add-on option, and here you get it just included with the software package. I found, however, if I switched both channels on, so I switch the second channel on, then it seems to bring the software to its knees, and the FFT looks just wrong. I'm not quite sure. It's doing the FFT of just the sine wave, is it? I'm not quite sure what it's trying to do there. So switch that off and then we get the correct response. But it's good to know that it'll do basic FFT, so it turns it into a kind of spectrum analyzer for repetitive signals. That's rather nice. Of course, you can use the PC software to save waveforms as you're capturing them, but you can do a bit more than that. You can save waveforms on the device itself and then view those waveforms on here, and you can scroll through them all. But furthermore, you can then use the software to view these waveforms as well. So if you're out in the field capturing some certain signals that you can't do when you're near a computer, then you can capture them here and you can view them later on the computer. That, for some applications, could be extremely useful. So you can view these waveforms on the PC, but you have to kind of know what your number is. So here we're going to look at see if we can see 1, 2, 3, 4, 5, 6, 7, 8 and load waveform 8. I found this all a little bit clunky actually. It feels like this part of the software needs to be improved. One of the things also is you have to exit that view. Provided you're out of that screen, then you can load it in the software, but you have to know the ID number of the file you're trying to view. I'm finding that all a little bit sort of clunky and maybe a little bit unfinished. So there's potential for that software to be improved slightly. In conclusion then, what do I think of this? Well, I think for the right use cases, it's an excellent piece of kit. So if you're looking at low frequency waveforms, or high frequency, which are repetitive, if you're, for example, doing stuff with audio, which tends to be quite repetitive signals, it can be absolutely brilliant for that sort of thing. It's less good, of course, for waveforms that you need a very high sample rate capture, but of course you couldn't use a small device like this for that. You're looking at a much more expensive piece of kit for that. If you're going to get one of these, well, one, I'll have some more information in the notes below, but listen, there's a version of this with one scope probe and a version with two. You could use the one scope probe and then use the clips for the other channel when you're not using the signal generator. But really, come on, get both scope probes. It'll be easier to use with both scope probes. Now, some of the things I found that were less than brilliant was some of the software had some little problems, but that's no reason not to get it because, of course, TOOLTOP can fix the software later. That's relatively minor. I particularly like the portability of it. I like that it's USB-C capable and rechargeable for applications where you need to go out on the road or you need something very portable that you can keep in your pocket to make quick measurements on the go. I mean, there's nothing quite like it. It's a really good little product for that. Now, my first oscilloscope, when I was a hobbyist and I was a teenager, was an old Heathkit one, 1967 vintage. This actual scope, and I loved it, and I kind of regret selling it. I would, when I had that thing, or prior to getting that thing, would have done anything for this because this is so much more capable. You can capture single shot waveforms to some extent with this, which you just can't do with that old-fashioned type of scope. The frequency response on this is massively better. It's got so many more useful features and it's nice and compact. So I'd have done anything as a youngster to have got hold of a good scope like this, and I would recommend it in particular for people who are setting out, people who are maybe just do a little bit of dabbling in electronics, or people who are, like I say, their waveforms are quite repetitive. So it certainly has its uses. I hope you've enjoyed me working on this. Now, I normally work on audio and video equipment. Of course, you saw me earlier working on that Betamax video recorder. So I'll do plenty more content of that type in the near future. See you then. Bye for now. You'll actually see me using this one on my workbench in the future because it's really handy for simple checking of waveforms. On a different day I tried this FFT with 2 channels and it seems to work just fine.